Today we're going to dive into lesson 104 today. We're going to find the lengths of semicircles and the areas they enclose. We're going to find the lengths of arcs that are not semicircles. And we're going to find the area of sectors of a circle that are not semicircles. So we're going to start with the semicircles. Then we'll move to different sizes of the shapes. Alright, so first of all, definition of a semicircle. It is half of a circle. Okay, the length of a semicircle, which would be this part, is half of the circumference with the same radius. And then the area enclosed by a semicircle in its diameter then would be half the area of the full circle. So that might give you a clue how we're going to determine the length of the semicircle or the arc produced by a semicircle and the area of it. Alright, so let's say that we have a shape somewhat like this. Okay, obviously you have a rectangle and then you have a semicircle. And they want you to find the perimeter. So first of all, let's take a look at just this part. We've got the rectangle there. And we know that this side along here is going to be 12. Because the radius here was 12 or 6 and the radius here was 6. So to find those three sides, we would add 4 plus 12 plus 4. Alright, we're going to hold that in reserve for right now. That would be 20. Now the part that we've never done before is to find the semicircle here, the distance around this. Well, that would be half of a circle, which would be half of the circumference, because the circumference is the outside of a circle. So we would have circumference equals pi times diameter. We're going to use 3.14 for pi in this case. The diameter is 12. And that gets us, let's see here, 3.14 times 12, 37.68. Now, that's the entire circumference of the circle. We only need half of it because we have a semicircle, so we're going to divide that by 2. And it comes out to be 18.84. To find the perimeter of the whole thing, then, we're going to add the 18.84 to the 20 meters. This is 84. And it would be 38.84 meters around the outside of that shape. Alright, now let's take a look at the same shape, only this time we're going to find the area. Alright, let me get just a smidge thicker pen here. There we go. Alright, so let's do the same type of thing. We know that this side is 12. Let's find the area. We'll call this area 1, and we'll call this area part 2. Okay? Area 1 is a rectangle, so it's length times width. 12 times 4, that gives us 48. It would be square meters. I'm not going to worry about the label right now, though. Then to find the area of the semicircle, well, let's find the area of the circle itself first. So we have pi r squared. That's 3.14 times 6, which would be 36. That gives us, let's see here, 113.04. That would be for the whole circle. If I cut that in half, then, that gets us 56.52. We add that to the 48 for the rectangle. Oops, excuse me, that's 56, not 58. We add the two areas together. And we have 104.52, and it would be square meters because, again, we were finding area. So, to find the area of that semicircle, then, we just find the area of the whole circle like we did here, and then cut it in half. Alright, let's take a look at this next slide. Now, we've talked about a semicircle. What if it's not just exactly half a circle? What if we have just a portion of the circle? They call that a sector. So the sector is all the stuff I have shaded in green there. And then the arc would be basically the perimeter of that as far as the outside of the circle. Okay, and it says it's a portion bound by two radii. Here's a radius, and the arc is the outside of it. So as we take a look at something like this, what if we had to find the area of this sector? Well, let's figure out how much of this circle is included in this sector. And with that, we're going to go with a fraction. So we know if this whole thing out here is 300 degrees, that means the part inside the sector is 60 degrees because a circle is 360 degrees total. So 60 out of the 360 of the circle is included in the sector. So that means 1/6 of the circle is included in the sector. That means if we find the area of the entire circle, pi r squared, and we take it times 1/6, that will give us the area of this, just the sector itself. And I'm going to kind of shade that in here real light. It'd be this part right here. Okay? All right, so let's see, we've got 3.14, we'll use that for pi, times the radius, which is 25, and we divide that all by 6. All right, run that on the calculator here, 3.14 times 25 divided by 6. 13.083 repeating. Okay, or you could have used it as a fraction, which would have gotten you 6, and that would have been fine also. And this is area, so it is square centimeters. All right, let's take a look at the next slide here. When we're talking about arcs, we really haven't talked about arcs before, but they are listed if it's a minor arc, and that would be something less than half a circle. We just list it with 2 letters, A to B. Okay. If we want the other part of the arc that goes here, A, B, and all around to C, that's called a major arc. Then you need to list 3 dots on the circle. If I just said major arc AC or arc AC, they would think it was the green one. We don't want the green one. We want the major arc to represent the red. So major would be more than a half circle, needs 3 letters. Minor arc, 2 letters. All right. In this figure, central angle AOC, this one right here, measures 70 degrees. So what is the measure of the major arc then? Let me get another color here. AOC. Actually, that should be ADC for the arc. I'm sorry. That should be ADC. Or maybe it's the angle here that measures the arc. Okay, well, 360 would be the whole circle minus the 70 would be 290 degrees. That would be the measure of the angle that would form the arc ADC. All right, here's one on a coordinate graph, a minor arc with a radius of 2. Centered at the origin. Okay, so the origin would be considered the center of the circle. Is drawn from the positive x-axis to the positive y-axis, so they made a little arc here. What's the length of the arc? Well, first of all, we would need to find the circumference of that entire circle. All right, so circumference equals pi times diameter. If I extended this, we would know that the other point on the x-axis would be over here, so our diameter would be 4. That makes the entire circumference 12.56, but we only have 1/4 of the arc, or excuse me, 1/4 of the circles included in the arc. So you would divide that by 4, and it comes out to be 3.14 would be the length of the arc. And since it's on a coordinate graph, we can just use units for our unit of measure, our unit of length. Alright guys, now what I would like you to do is go to page 727. I would like you to do A and B, and I think that's all. Let's just stop with A and B today. Find the perimeter of that irregular shape, find the area of that regular shape, and then we'll talk about the sectors then as you get into your homework.